indispensable part of our lives.
It slips through the window cracks every morning, dances on the water surface as dusk falls,
And even guides night flights through the starry sky. We've grown accustomed to light as a companion. Something so familiar that few stop to wonder what it truly is. But what if I told you that at its smallest level, light could tell a completely different story?
A story about 37 dimensions of space, where everything you think we know about the universe
Might just be a small piece in a larger picture?
In early 2025, a team of scientists announced a quantum experiment that made the scientific community turn their heads.
They discovered that light, or more precisely photons,
The tiny particles that make up light could exist in 37 dimensions of space simultaneously.
No, this isn't a science fiction scenario, where we step through portals leading to mysterious dimensions. Instead, it's a discovery about how light behaves in the quantum world, a world where the ordinary rules of daily life seem to bend, even break completely. This experiment isn't just a dry scientific breakthrough. That's like a whisper from the universe suggesting that perhaps we dawn. So what happened in this experiment?
Why are 37 dimensions important?
And more importantly, are we misunderstanding the universe? Before diving into these strange dimensions, let's take a moment to reacquaint ourselves with light. Since childhood, we've learned that light consists of rays traveling from the sun to Earth, carrying energy and color. Great scientists like Newton separated light into rainbows using prisms, while Einstein later showed us that light can also bend around massive objects like black holes. But in the 21st century, light has revealed a new aspect.
It's not just waves or particles, but a phenomenon called wave-particle duality.
Photons, the smallest units of light, are the main characters in this story. So small they can. In the quantum world, photons don't just move from point A to point B. They can be in multiple states simultaneously, a concept called superposition. Moreover, they can become entangled with each other, a magical connection where the state of one photon instantly affects another no matter how far apart they are. If you measure a property of one photon like its rotation direction, called spin, the state of the other photon changes immediately, as if they're communicating through an invisible line. That's this entanglement that led scientists to the experiment we. But first, prepare yourselves. We're not just talking about the familiar three dimensions of length, width, and height, but a strange mathematical space where 37 dimensions are just a way to describe what photons are doing. These aren't dimensions you can step into, but coordinates in an imaginary world where quantum rules reign.
On a cold winter day in Denmark, the research team led by physicist Daniel Wu from the Technical University of Denmark flipped the switch on a complex device.
They were seeking answers to a question that had puzzled physicists for decades. Does reality really work the way we think it does? Their experiment was based on an idea called the Greenberger-Horn-Zeilinger paradox, named after the three physicists who conceived it in 1989. This paradox is a thought experiment showing that quantum mechanics contradicts the classical view that everything in the universe has a fixed state, only affected by what's nearby. In classical theory, you could predict the outcome of these measurements based on the assumption that each photon already had a predetermined fixed state. But when conducting the experiment, the results contradicted classical predictions and perfectly matched quantum mechanics. This suggests that reality isn't something fixed but depends on how we observe it. Wu's team used photons to test an extended version of the Greenberger-Horn-Zeilinger paradox. They created a special state where photons were entangled in such a complex way that it required 37 dimensions in a mathematical space called Hilbert space to fully describe. Hilbert space sounds complicated, but it's actually just a tool scientists use to describe the quantum world. Think of it as a giant spreadsheet where each column and row represents a possibility that a photon could exist in, like its position, spin, or entangled state.
In simple cases, a photon can be described in a two-dimensional Hilbert space.
For example, it could spin up or spin down.
But when you add more photons and make them more complexly entangled, the number of Hilbert space dimensions increases.
Each dimension isn't a physical direction like left or right, but a mathematical parameter to record all possible states.
In this experiment, scientists created an extremely complex photon entanglement state, requiring up to 37 dimensions in Hilbert space to describe it.
As a result, the photons appear to break all classical rules.
They don't just exist in one state or one location but seem to spread across these 37 dimensions, challenging the notion that reality is simple and easy to understand.
One of the most interesting aspects of this experiment is its potential to change the technology we use daily, or at least the technology our descendants will use in the coming decades.
To visualize this, think of the computer you're using right now. It operates based on bits, the zeros and ones processed through tiny electronic circuits. But quantum computers are different. They use qubits, units of information that can simultaneously be 0, 1, or both due to the phenomenon of superposition. The experiment took this idea to a new level, with photons entangled in a state so complex it requires 37 dimensions to describe. They have the ability to carry and process a massive amount of information compared to regular qubits. With more dimensions, quantum computers could solve problems that current computers would take millions of years to process.
In everyday life, we often believe the world is a certain place. If you place a coffee cup on the table, it will stay there until you pick it up. But quantum experiments show that at the microscopic level, things aren't that simple. Test results reinforce the idea that reality ISN. When the photons in the complex entangled state are measured, to be explained by the classical view of local reality, where things are only influenced by what. Instead, they seem connected through an invisible network,
transcending space and time in ways that classical science can't explain.
This is like discovering that the world you live in isn't a static picture but a movie. And you only see a few frames out of millions happening simultaneously. It makes us wonder, if reality at the photon level is this complex, what else haven't we seen?
Are the 3 spatial dimensions in one time dimension we perceive just a small part of a larger picture?
Scientists call this the collapse of local realism. But you don't need to be a physicist to feel its impact. That's like the moment you realize Earth ISN.